So that was the relative frequency approach. Now moving on to the subjective approach. The subjective approach or subjective viewpoint regards the probability of an event as a measure of the degree of belief that the event has occurred or will occur. One of the significant advantages of this view is the ability to discuss the probability of events that cannot be repeated. Okay, so I'm not a big fan of anything that's subjective, but you know, if you, let's say you were to talk to 100 students that I've taught statistics, and you ask them, you know, what are my chances of getting an A in his class? And they say, well, almost everybody in my class got an A. Well, then the probability would be pretty good, right? Maybe close to 100% or something like that. But you know, if you take a teacher that more than half the class drops, and you know, that person is known not to be very generous with their grading, then you know, maybe the probability of getting an A would be a lot lower. So the subjective approach is a probability that maybe you could talk to someone and figure out, maybe with life experiences. It's probably used a lot between you and someone else and you don't even know, but you just kind of use common sense to figure something out, if that makes sense. So the next approach that we're going to look at is the classical approach. This approach makes a lot more sense. We can measure a probability as just a simple proportion. And the way that we write the probability of event A occurring is P of A. This notation means the probability of event A occurring. And that's equal to the number of simple events in A divided by the total number of simple events in the sample space. In a way, this is, the classical approach is part over total. So, for example, if I wanted to know the probability of getting ahead when I toss one coin, there's one way that can occur. That's if the coin lands on heads. Over, there's two different ways that, or events that can happen when I flip a coin, right? It can land on heads, it can land on tails. So in a way, this is kind of like part over total, the part that happens over the total number of events. So you can see the probability here is 1/2. Now, what if I wanted to know the probability of, let's say, having two girls out of 3 births. Assuming that the probability for having a boy and a girl is the same, if we were to look at our sample space up here, here's the sample space for having boys and girls. if we have 3 children. And so if I want to know exactly, I probably should have put exactly. I didn't put at least or at most or anything like that, but let's say exactly 2. So we have 8 different possibilities. 3 of those possibilities have 2 girls. I know this one has 3, but let's just assume that we want to know exactly 2 girls. So 1, 2, 3, and there's 8 total outcomes. There's 8 different outcomes, or 8 different simple events here in my sample space. So that's going to be equal to 3 over 8. So convert that to a decimal. We got a percentage there. Then you can see the probability of having exactly 2 girls out of 3 births. It's very important to remember that this classical approach here rests on the assumption of equally likely simple events. If the assumption is not reasonable, some other method of determining the probability must be used. So, you know, if I have, say I have a die, and instead of having 1 through 6 on it, it has 1, 1, 1, 2, 3, 4. Well, there's not an equally likely outcome for 1 as there is for 2, 3, or 4. So we need to have equally likely outcomes when using the classical approach. If not, then we need to figure out, or there has to be some other way of figuring out the probability. All right, and that ends 6.4.